I'm Jennifer Sands. I'm CEO and co-founder at a company called Codential. My background is actually in large-scale, very distributed SaaS environments, typically for mission-critical applications. So previously, I was VP of product at a cloud security startup called CloudLock, which we exited to Cisco. And then after that, I led the product strategy at a company called Everbridge, which is responsible for tracking and managing global physical and digital threats for some of the largest enterprises and governments in the world. So given that background and the experiences that we had there, that's what we're bringing to Codential to build an AI code verification solution to make sure that the types of issues that we're going to describe today don't leak out into production environments as we have experienced them throughout our careers.
Thanks, Jennifer. My name's Brandy. I've worked in the industry for quite a while. I've worked at companies of various sizes. I was with Jennifer at CloudLock and to Cisco for a number of years. I worked at Toast, leading large engineering teams, working on delivery, meaning food delivery, not just software delivery. And I have a background generally in deep tech area, architectures, patterns, and verification. And so happy to be presenting what we've been working on to all of you.
So what we're going to talk about today is less about a demo of our product, which we're happy to do later offline, but also some of the core tenets that are driving what we're building and why we're doing it. So based on the years of experience delivering these types of mission critical systems, what we have learned is that despite all of the QA methodologies and solutions and headcounts and everything that we throw towards code quality, there are some types of issues that always still seem to make it out into production. And usually those are the issues that wake up your on-call engineers at 3 a.m. and send your largest enterprise customer screaming at you and your engineering team on a 3-week death march to try to root cause what happened, why it happened, and how you can prevent it. So the reason why these things happen is because testing does not capture or catch these types of issues, because testing is focused on identifying specific test cases, and it misses a lot of edge cases and concurrency issues that only occur in real world scenarios when code base meets infrastructure, meets your favorite enterprise customers' data, et cetera. And just because testing doesn't find bugs when it's executed, that does not mean that no bugs exist. And so there are all these different types of things that tests can often miss. And what we found is these are also the types of issues that coding agents will silently inject into the code that's being created. And then the code may pass every functional test, but these subtle architectural issues still make their way into production. And then you don't identify them until you've forgotten about what the code was and you've shipped it and it's 3 months later, and then you have to go back and fix all of that. I want to point out here also, there is a bit.ly link here. So we're going to be walking through some examples of the types of issues that we're identifying in AI-generated code. And we're going to show you a tool that you can use today and take home with you to prevent AI agents from generating that type of code in the first place. And if you want to follow along, or if you want to access the GitHub repo that we're leveraging for the demo purposes, you can do that through this bit.ly link that's going to be on every slide as we progress. So let's talk about 3 categories of very difficult to test problems. So, we're calling these untestable, and certainly, there's ways that you could test for them, but it's not practical or pragmatic necessarily to do so. So, in a category of too hard to test, race conditions is just a great example of that. So being able to test for race conditions requires that you think up front about what are the race conditions that could occur and the variety of them, and then construct tests to do so, right? And then you have to have the luck of the test executing perfectly in order to trigger that, right? So being able to test for that is too difficult to actually bother and plan for. Too expensive to test. So, everyone does performance testing to some degree. We do load testing. We do all the various kinds of testing. Those are really focused on acute load in most cases, and there's so many different performance characteristics that only show up under sustained load over a long period of time. And when you think about what would it cost to actually replicate that in a test environment, it requires duplicate infrastructure, duplicate production level data, and the tooling in order to generate that sustained load over time, right? And that starts to become prohibitively expensive. Too complex to test. This is one of my favorites. So combinatorial state explosions is a super fun phrase to say. And when you think about all of the different permutations and states that you're managing in some scenarios, it means that you would have to write so many tests and execute so many tests for all of those permutations that, again, it becomes prohibitively expensive in both man hours and cost in order to do so. So in these three categories of bugs, what we're going to do is we're going to walk through some specific examples of what we can identify, and then we're going to show you a demo of a coding agent producing code that creates these problems, followed by an example of the coding agent being prevented from creating these issues in code. So in the too hard to test category, race conditions in transactions, we're going to show you an example, just super simple, where if two users try to buy the last item in stock simultaneously, or they encounter a soft failure, right? So in this case, tests can miss this primarily because it could be a flaky test. It's an intermittent failure, typically in testing. And so you're always going to question, is this the test failing, or is this a real issue, right? And so every time the test runs successfully, then you're going to question that again. And it's really difficult to write multi-threaded tests that could capture that. And then you would also have to invest in the simulation of it, which would require you to think about all of the potential test cases up front. So we're going to demo an example of this type of too hard to test race condition using two users simultaneously purchasing something. The next example that we're going to walk through is in the too expensive to test category. So some performance characteristics. And the example that we're going to use is when you query data from MongoDB without using lean. And it returns the data correctly. It's functionally correct, but it returns the entire Mongoose document as opposed to just the plain JS object that you need to display, right? And so this is something that will pass the test, and you wouldn't necessarily detect it. And even if you're doing some sort of performance testing, test databases are small, and so the memory impact would not necessarily be visible unless you're doing a production data set test, right? That would be prohibitively expensive in a lot of cases, especially at enterprise scale, and it would require a lot of time to create that slow load where it would in fact become a problem. And then the other category, in terms of too complex to test, the example that we're going to leverage for this is around basically verifying the validity of a product at various states. So when you're thinking, if someone adds something to the cart or the user takes some action, for each of those actions, you want to be able to verify, is this a valid product to perform that action on? And that takes into account not just is it available or not, that's a super simplistic example, right? When you're thinking about enterprise scale inventory states, especially with distributed warehousing, then you're in a situation where it could be in stock or out of stock, certainly. It could be discontinued, it could be in transit to the warehouse, it could be in all of these different states. Then you have to think about the state of the cart. You have to think about the different product lifecycle events, and then each of these validations has to occur depending on the user action. And so when you start to multiply that out, you're now in a situation where you have over 2,500 possible permutations of things that you would validate, and I don't know that anyone is going to write 2,500 different tests to make sure that that is true. So another example is we have a design partner who we're working with that is producing software that allows their users to create custom workflows, very complex workflows. There's no possible way that they can test for every combination of workflow. So you start to see where this appears in other types of software as well. So essentially what we're saying is with invariants, you can verify not just does the code work, but is it correct? And so historically, we write code, we write tests, the tests pass, and we ship it, yay. And what we're saying is that actually, if you think up front about the things that must always be true, and then you instruct the agent to write code that takes those things into account, the agent writes the tests, and then you can verify that those things are in fact still true, then you can go through your testing and your test pass and you ship. So what we're going to introduce as a mechanism to help guide the agent toward code correctness is an invariant verification taxonomy. So this allows you to define the scope. So is this universal across any code base? Is this just a rule that everyone should know that should be true? Or this is like battle scars that engineers earn over time based on their experience? Is this something that is specific to your code base? Or is this something that is feature specific? So defining that scope. You can define the type of invariant that it is, whether it's performance-based or logic-based. And then once that invariant is verified when you're violated, when you're verifying it, what should be done about it? Does it just send a warning? Does it fail continuous integration? Or do you ask the agent to implement a fix? So I'm going to play a video demo that Brandy's going to walk through in terms of the show and tell here. Yep.
That'd be great. Thank you so much. So just show of hands, who remembers from maybe a computer science class invariants? Remember invariants? You got 1, 2, and then how many people remembered invariants after that semester? How many used them actually after that one class? I think I did them back away in my undergrad. Some algorithms class where we had to do some invariants in some weird language that did them, and then they kind of just fade in the background. Well, they're here and they're real, and they actually really help when working with agents. So what we put together is a simple shopping cart app. Everyone has access to the same source for this, so you can follow along, look afterwards. Threw the app together in Claude Code, asked to generate test coverage, generate 100% test coverage, and well, as we've seen, obviously we have a talk, so it's not perfect. So first one we're going to walk through is the too hard to test. So this is the reserve items method. So this is a key method. It's a shopping cart. Shopping cart has two key pieces. I need to get an item and I need to pay. So on the reserve items, very straightforward flow. You just back up here. And
yep.
Thanks. Thank you. And just pause maybe.
Yep.
Thank you. So very simple functionality. Find an item, check the quantity, put a reservation in, and then update Mongo. This works perfectly fine, of course, until there's an error. Notice it just returns false, and there's no back out of a reservation. Notice that if multiple threads hit this at the same time, find one returns one count, then the next time another thread comes in, gets the same count, then they both hit the same time. Okay? Very typical. We do a lot of AI-generated code. This is a very typical pattern that comes in. And so let's see how we can address this. And so we can just sort of click along in the, okay, there we go. So this is, so we're going to consider this a global concern. So we want to make sure our Mongo transactions are fine no matter what project we're working on, okay? Imagine if you work in Postgres or SQL, you'd have an equivalent for this. So we threw together this invariant.md. We consider this the global one. So you would take this file and drop this into your, your source, your root folder, some root agent folder, so it's picked up by whatever agent there. And there's a structure that we showed a little bit earlier. So we have a description of what this issue is about. You can just advance a little bit. There we go. Thank you. What it's about, we give examples. We talk about why this is important. So it's important to tell the agent a positive example and a counter example. So this is what the good code looks like. This is what the bad code looks like. And then most importantly, we tell it, here's how to verify that this is correct. Okay? So there's a whole lot of different methods you can choose to verify, and it's going to depend on the actual severity and criticality of this to your organization. Okay? This one, getting transactions rate, this seems pretty important, so we want to make sure that we're actually checking this properly. So we saw from the prior talk that if you just use the same agent and say, hey, does this violate transaction stuff, you're not really sure what you're going to get. So we threw together a little MCP server that just gets this called transaction analyzer, does some very hacky regex on transactions, and then sees what it's about and returns information back. So you'll notice that we ran this over the code. Claude talks a lot about if we found this issue in this spot, this spot, this spot, didn't find it here, what do you want to do for a fix? Okay? And then it's set up there so as you generate more code, it's going to start invoking that MCP server at the right time and get you the feedback. Okay? The next one we're going on to is the too expensive to test. So let's just fast forward to where it drops into the, zooms into the. So too expensive to test. This is the one where it's perfectly fine, and it's fine maybe for months and months and months in production until all of a sudden you hit Black Friday and you're out of memory on your servers. So we use Mongoose on our own system, and this happens very easily. It generates great queries, and it forgets .lean on read-only. So .lean strips everything out. It's just very performant, much easier. But in this case, it calls exec and then immediately calls toObject, and so that creates a bigger memory blip. Very typical pattern. Again, this happens to us in our own code until we put this in, and now it doesn't happen. So let's fast forward. So we generate an invariant for this. We're going to consider this a project scope. Not every project we use has Mongoose in it. And so we don't want to just sort of mess up our global context. So let's just put it into our project context. Okay? Same structure again. I'll go through a little quick. We explain what this is about, how to apply this, examples of it looking bad, examples looking good. And then we'll fast forward and we give this to Claude. We say, hey, go take a look at this function with these invariants. Tell me what you find. And we'll see that, and again, because this is a little less critical, we just ask Claude to do some code inspection, like a code review. Okay, so just look at the generated code. We don't really need to go out to another server or have a lot of harder check. We'll just do some review on it. And so it goes through, it finds a bunch of issues. Then we ask it, generate a new get items below price for me. And we fast forward a little bit, it generates it with the .lean automatically for us. And so showing that this has been incorporated in. Okay? Third example, the combinatorial state. So in the bounds of the demo, I can't show you a great way to check all 2,586 states at once. But what we want to do is make sure at the end of the day our system is not broke. Okay? So we have the simple add item method, again, key part of a cart. And when we look at this, again, very simple demo app. There's already a lot of validation that happens. It's going to be a correct item. The price has to be OK. Not negative quantities. There's like 4 or 5 different checks in this. It's not checking reserved items, not checking stuff coming from the warehouse. That's stuff that we'll build out later in this. But what we want from this invariant is we want to make sure that whenever we're done with the inventory, that it's in a consistent state. Whatever operations happen to got there, we're just putting in a backstop at the end. Okay? So this is a different technique. So we'll go ahead to the invariant. Again, explain the same sort of stuff, give an example before and after. And in this case, we want to do it with some pre-save and pre-update hooks. Okay, so showing a different technique. And so this way, it's a hook we can put into Mongoose. There's database triggers you do in Postgres or equivalents in your favorite persistence layer. And this is just going to say, before I commit a transaction, I'm going to go run this validation at the Mongo level. And if it doesn't work, I'm going to fail with, I'm going to fail at runtime with a clear message. Okay? And so what we want is, we want the agent to incorporate this in and make sure these hooks are used properly throughout the application within the shopping cart module. Okay? We don't want this invariant doesn't need to be in all the other aspects of the shopping cart. It's scoped to this project, to this set of functions module within the project. Okay? And then we show an example where we just ask Claude to do an analysis and see how we are against this. And then it detects where we had a miss. And now it goes and it starts creating those, and it'll go and fix that for us. Okay? And you can imagine a similar invariance for the other schemas in the system. And so showed 3 different ways, 3 different techniques, 3 different scopes. There's a lot of different other approaches you can take to check the invariant, to enforce it. How do you instruct it? But this structure that we put together, we found has been, it's been quite effective for what we've been working on. So I want to give everyone some action plan. I want to give some homework for folks. And it was the end of the day, so this will stick with you as you go to the party. So you'll be sitting there saying, what did the credential folks say I should be doing tonight? Oh, yes. So what we'd ask of the group, come up with 3 things in your, that you're working on, maybe feature level, module level work. What are 3 things like you wish that the agent just stopped doing or started doing for you? Think about the framework that we put together. Again, go download the stuff. There's plenty of examples. Just take the template in. There's instructions on how to get, there's an agents MD that you can just feed in on yours, and it'll get the agents to start using the things. And what are 3 things you want to get? Drop that into your system, start playing with it, and just look at the before and after difference. Okay? Very simple steps here. Okay? Then this month, so now, okay, this week, it's, today's Wednesday? Wednesday, okay. So that's this week. You get the next month. We got a couple of holidays in there, but we got time the next month. So what you want to do is start building that a little more and get some better verification using this on your code base. Think about what things do I want to block in the CI/CD process? What things do I want to prevent from merging? Okay? So you can use the agent to go and put these checks in place into Git if you want, or you can operationalize other processes in your org. Then this quarter, start to build out an invariant library, right? Start to incorporate this into your design process. Start to get the agents to create the invariants for you as you go along with it, instruct it as part of your spec-driven development, and start to get the benefits through this. So I'm going to turn it back to Jennifer for the end.
So what we showed today is really a tool that you can start using immediately, that you can leverage in your coding practices today. At Codential, we are building a solution that identifies this class of bug, these types of issues, as well as many other functional logic, memory safety bugs as well. So if you're interested to learn more about what we're building and how we're doing it without having to deploy, test, execute your code, you can find us at codential.ai. We have our wait list up and ready on our website, so please reach out. We'd love to chat more. Thank you.
Thank you so much.